Hi there. I'm glad we found this quiet together. Tonight, we'll follow a pair of small travelers with big patience. Voyager 1 and Voyager 2, tiny craft that slipped past the giant planets and kept going, past the sun's protective breeze, out toward the deep where interstellar night truly begins. We won't rush them. We'll walk beside their faint signals, listen for the soft hiss of plasma, and trace the edge called the heliopause, where home thins and the galaxy begins. This is a lullaby made of star maps and distant beeps, a story to hold while sleep unknots the day. If this quiet journey feels like a good place to rest, a small like and a gentle subscribe help others find it too, only when it feels right. For now, let your inhalations lengthen, your thoughts grow light as dust in a sunbeam. Close your eyes. The Voyagers are still talking, and we'll listen unhurried, warm, and together. The world once lay awake for different reasons. In the late 1960 seconds and into the 70 seconds, nights were crowded with unease and wonder. A long standoff stretched thin between superpowers and ideas. The Cold War hung like a low ceiling, never breaking into the storm everyone feared, never letting the air clear either. Across that tense hush, another kind of race unfolded, one that lifted the eyes instead of narrowing them. Two nations stared across oceans and found themselves staring past them toward a sky that promised both danger and release. Space shifted from a battlefield of guesses to a place where imagination could breathe. A single night in 1969 rewrote what seemed possible. A grainy glow on home televisions, a calm voice on the radio, a boot print pressed into dust that had waited 4 billion years for company. For a heartbeat in history, it felt as if the planet inhaled and exhaled together, while Neil Armstrong and Buzz Aldrin moved like careful swimmers in a gray sea. That moment wore the word "we" without needing to explain who was included. It felt like the world had leaned over a balcony and seen itself from above. Then the quiet, after a great chorus came, returning to the moon again and again, did not sing the same way. Curiosity didn't vanish, it changed tempo. Budgets tightened, plans thinned. Big dreams were folded like maps and put on a shelf. The question that arrived was a gentle one, but it carried weight. After the highest peak, where does the trail go next? The answer was waiting beyond the reddish arc of Mars, where the giants keep their own weather. Jupiter with its marbled storms, Saturn wrapped in light rings, Uranus and Neptune tuned to colder blues. They were distant, heavy with secrets, circled by moons that glinted like bells you could see but not hear. For years they were little more than smudges and guesses, beautiful, untouchable, kept apart by distance and the limits of earlier rockets. Reaching even one of them would be like leaning over the edge of a continent. Reaching several felt like a daydream with math attached. The numbers stretched long, hundreds of millions, even billions of miles, distances that turned seconds into hours and signals into whispers. To move a small machine that far and have it still speak back is like asking a candle to reach the shore from across an ocean. Yet sometimes the universe tilts the table just so. About once every 175 years, the outer planets arrange themselves along a path that lets a single traveler hop from one gravity to the next, each world lending a little speed and a new direction. A cosmic hopscotch, yes, but also a kind of kindness, a door briefly left ajar. The idea had a name that felt like a promise. The Grand Tour. It was born in the bright optimism of the 60 seconds, a many-craft ballet meant to skim past the outer planets and even brush by Pluto. Plans unfurled across drafting tables. The routes looked like music written in curves. Ambition breathes fast, though, and budgets breathe slow. When the adding machines finished their clatter, the grand tour was deemed too lavish for the decade that followed. The map closed. The dream did not. Dreams tend to recalculate. The tour returned in a quieter shape. 2 matching spacecraft, built with care and restraint, designed to share a sturdy body and a long patience. They would launch a few weeks apart on slightly different paths, with enough instruments to learn, enough fuel to steer, and enough toughness to keep working after headlines moved on. No one promised lifetimes. If they reached Jupiter and Saturn, that would be triumph enough. Anything beyond would be a gift. In 1977, as disco thumped and rotary phones clicked and clothes flared at the ankle, the build teams leaned into the work that would carry farther than any music on the radio. Nothing about it was easy. The technology of the day was brave but small. A digital wristwatch felt futuristic. The onboard computers would be modest even by kitchen standards decades later. The trick was not brute force, but elegance, simplicity with a spine. Each design choice had to hold up far from home, in sunlight that would dwindle to a thin thread, and temperatures that would try to persuade metal to forget its shape. Power was the first riddle. Solar panels are faithful near the sun, but out by Saturn and beyond, the light fades until even a mirror would shrug. So the craft would carry warm hearts, radioisotope, thermoelectric generators, little furnaces that sip the heat from decaying plutonium and trade it for electricity. They hum softly and don't care about night. They were compact, efficient, long-lived. The kind of solution that looks, in hindsight, inevitable. Distance makes everything quieter. To talk across billions of miles, you need ears the size of houses and patience that does not tire. The spacecraft would unfurl a high-gain antenna, a white dish like the face of a lily, and turn it toward Earth. On our end, a network of giant radio dishes would keep watch, listening for signals that would arrive thinner than the snow on an untuned television. The Deep Space Network was more than equipment. It was an agreement to keep listening long after the world had looked away. Through that narrow thread would travel pictures of storms and rings, magnetic size and particle counts, and a kind of music so faint it feels imagined until the numbers confirm it. Into this practical architecture, someone slipped a poem. If a machine is going to leave the warmth of the sun and drift for ages, perhaps it should carry a hello. A small committee of scientists, artists, and kind hearts, led by Carl Sagan, gathered sounds and images that could stand in for a planet. They pressed greetings in many languages, bird song and thunder, a baby's first voice, a mother's kiss, a Mozart line, a Senegalese drum, a night train crossing a track. They even recorded the quick, private electricity of a person in love and translated it into a pattern no one had seen before. A golden record, gold-plated copper, built to last, was bolted to the side of each craft like a promise tucked into a pocket, not a boast, a simple declaration: we were here. If anyone finds this, know that we tried to be kind and curious and musical. Inside the Jet Propulsion Laboratory, coffee cooled beside blueprints, engineers argued with affection over thermal blankets and camera focus. Programmers wrote compact symphonies of commands that would take days to arrive, then days more to report back. Scientists drafted wish lists and learned to trim them. Someone checked a wire twice, then checked it again. Someone else thought about dust, how tiny grains might sting at speed, and added a shield. The mood wasn't the drumbeat of conquest. It was steadier than that, like walking with a heavy pack toward a beautiful ridge, adjusting the straps so your shoulders won't ache later. This was endurance work. Poetry and plumbing, daydreams and data tables, the sparkle and the wrench turning the same bolt. Beyond the lab windows, the culture bent and swayed. Politics argued with itself. Prices rose and fell. The big, bright arc of Apollo had narrowed. Yet, in the middle of all that noise, these two small machines gathered the best of what humans can be when no one is cheering the patients to do exact work, the humility to let instruments speak, the willingness to build for a future audience we might never meet. In 1977, the idea of touching interstellar space felt like a bedtime story you tell to soothe a restless mind. Neptune was still a blue dot without texture, Titan a mystery under a haze, the outer edge of the sun's influence, more idea than line. And still the teams leaned forward with an almost stubborn gentleness. With enough math and enough care, with a little luck and parts that could forgive a mistake or two, maybe a pair of robots could outlast the calendar pages, could keep going when our attention wandered, could carry the ember of our curiosity past the place where maps run out. As the launch window drew close, the days took on a rhythm. Hardware arrived and was weighed, shaken, heated, and cooled. Instruments learned their first lessons in the vacuum of a test chamber. The cameras practiced on artificial stars. The propulsion systems hissed gently on the stand and pretended they were already far from home. Trajectories were refined until the lines were as clean as a bow on a cello. The record's instructions were engraved in a universal language of circles and timing, an invitation to any future finder who might not have eyes or ears like ours. Arguments flared, then softened, because there is kindness even in the way people disagree when they are trying to protect the same fragile thing. What they were building looked simple in silhouette: a dish, a box, a boom, a cluster of sensors, 3 RTGs on a short stalk, a long magnetometer arm reaching out like a cautious finger. But the simplicity was earned. Each piece had to be both delicate and stubborn. Each had to do its job without leaning on the others, in case something went quiet far from help. The computers, small by any later measure, were taught to be conservative and clear. If something confused them, they would pause, point the dish toward home, and ask for new instructions. The craft would sleep between tasks to save power, wake when needed, and learn to aim their cameras just so, while hurtling faster than any plane has ever flown. It's easy to think of such machines as cold, but the truth is, they were warmed by intention. People tucked hopes into them the way you tuck a note into a coat pocket before a long trip. The hope wasn't for glory. It was for continuity. We had touched the moon. We needed to keep our hand outstretched. The Voyagers were built to carry on the conversation, to ask planets soft questions about their weather and their fields, to glance at their moons as if seeing old friends for the first time, to measure the thin breath of particles that drift where sunlight loses its grip. At the edge of the Florida coast, the launch pads stood like matchsticks against a big blue day. Inside the fairings, the twins waited with their dish faces folded and their golden records glinting in the dark. The rockets beneath them were full of stored thunder. On checklists, boxes took their quiet marks. Words moved across headsets in unhurried voices. Someone looked up and tried to trace, with imagination more than sight, the curve from here to Jupiter. Someone else thought of the long winter nights ahead, when the signal would be faint enough to hide inside noise and still carry meaning, and how the deep space network dishes would listen anyway, patient as hills. They were not meant to come back. That was the point. and also the tenderness. Two small proofs that leaving can be an act of love, a way to make more home, not less. As the countdown slipped toward zero, the feeling wasn't triumph so much as steadiness. A hand at the small of the back, a door opening, a step taken. The flames that lifted them would be brief and loud. The work that followed would be long and quiet. That steadiness was no accident. It had been forged years earlier, when a different kind of courage put its name to metal and promised to keep going, to cross the place where the sun stops leading and starts whispering, and to send back postcards from the scenic route. Designing a thing to last a season is careful work. Designing a thing to last 40 years alone in deep space, with no pit stops, no spare parts, and no second chances, is the kind of vow you make with both hands on the table. That was the promise, quietly set into metal at the start of the 1,970 seconds. Two craft that would travel billions of miles, ask the outer planets to lend them speed, look closely at worlds no one had seen up close, and then keep going, slipping into the dark, while still sending home a thin, faithful thread of news. Durability came first, not the glossy kind that looks good on launch day, but the kind that endures cold and loneliness. Space is a hard neighbor. Temperatures lean toward the far side of winter, around 400 degrees Fahrenheit in the deep shade, and there's radiation, cosmic dust, and sudden gusts of charged particles that would make a household gadget faint. The solution wasn't to make the Voyagers sleek or fast, it was to make them stubborn. An aluminum frame formed the backbone, strong enough to ride the violence of launch, tough enough to stand decades of sunlight and particle strikes without forgetting its shape. From that core extended booms and instruments, and, like a white flower turned toward home, the high-gain antenna, a 3-meter dish that would become the craft's voice. That dish mattered more than its looks. Far from Earth, a signal thins until it is almost a rumor, a whisper, smaller than a billionth of a watt, fainter than the fuzz on an old television. And still, if the dish could aim with care, the deep space network's great radio ears on Earth could catch it. Giant dishes in California, Spain, and Australia would take turns listening, the planet's rotation turning into a relay, so the craft would rarely find us out of reach. Through that slim channel would arrive photographs, magnetic size, the pulse of charged particles, little line-by-line images building themselves like dawn. Inside, the brains were modest by any later measure. Each Voyager carried about 69 kilobytes of memory, enough in that era to feel brave, enough now to fit on a single old floppy with room left for recipes and a quiet game. Small minds, but well-mannered ones, radiation-hardened, steady, and simple enough to keep their heads when space threw tantrums. There were no glossy touchscreens, no lights meant to entertain, just solid-state logic, stepwise instructions, and the patience to wait for answers from a blue dot so far away that a round trip for one message could stretch toward a day. The craft learned a kind of politeness: do a thing, confirm it, look toward home, listen. Power was the next riddle. Near Earth, sunlight is generous. Out by Saturn and beyond, it is a pale thread, a whisper you have to lean in to hear. Solar panels would have become dead weight, so the Voyagers carried little hearths instead, radioisotope thermoelectric generators, or RTGs. Plutonium-2, 3, 8 decays and gives off heat. The RTGs sip that warmth and turn it into electricity, a steady trickle that doesn't care about night or distance. Each craft left Earth with 3 RTGs, delivering roughly 470 watts about what it takes to run a few bright bulbs and a kettle. The output falls slowly, year by year, like embers settling. Even so, decades later, the generators still feed the most essential instruments, just enough to keep a handful of senses awake. Power management became a gentle art. What to keep, what to darken, how to choose between a warm heater and a hungry instrument. It felt a little like living off-grid, with a tired generator, lights, or fridge, not both. The instruments themselves were chosen like tools in a careful backpack. 10 main systems rode on each craft: cameras to catch the faces of planets, spectrometers to weigh the colors and learn what the colors mean, magnetometers to feel for invisible fields, plasma detectors to taste the solar wind, cosmic ray sensors to count the hard rain of distant events. The cameras, humble by modern standards, still found poetry in storms and rings, the tangled belts of Jupiter, the braided music of Saturn's rings, the cool blues of Neptune. Mounted on a long boom, the magnetometer stretched away from the spacecraft's own faint magnetic personality so it could feel cleanly for planetary fields, and, later, for the change in texture at the edge of the sun's domain, the place where the solar wind thins and the interstellar medium begins to breathe. That long arm became a fingertip reaching into an invisible world. Radiation was not just a background concern. Near Jupiter, it is a chorus. The giant planet's magnetic field is so strong that Earth's feels like a fridge magnet beside it. High-energy particles can flip bits, scramble logic, and bruise sensors. The engineers answered the way careful people do, by tucking the most delicate parts behind protective plates, by arranging components so that one might shield another, by choosing materials that shrug off a part of the storm. They could not make the Voyagers invincible. They could make them lucky and sturdy and able to recover their footing after a shove. Simplicity wasn't an aesthetic choice, it was survival. The craft didn't need wheels or wings. They would never land, never scoop soil, never fire retro rockets to come home. They had no backup computer waiting in a tidy slot, no parachutes folded for emergencies, no way to send a mechanic to tighten a bolt. What they had was a plan that fit on a note card. Fly by, observe, transmit, repeat. Concentration turned into quality. Wires were checked, then checked again. Soldered joints were placed like stitches in a favorite coat. The clean rooms were as calm as winter libraries. Even breath was managed. When you build a traveler that will soon be farther from help than anything ever made, excellence stops being a wish and becomes a duty. Navigation had its own grace. In a sky without landmarks, you keep your bearings by the fixed ones: the sun, the bright stars, the slow drift of known planets. Gyroscopes felt for rotation. Star trackers recognized patterns the way a sailor recognizes constellations. The spacecraft would turn with care to take a picture or taste a field, then swivel back to aim the dish toward Earth and speak. The motions were unhurried and precise, like a dancer checking the floor between steps. There was no real-time map whispering corrections in their ear, only geometry, memory, and the gentle pull of gravity along a path planned in ink long before launch. Debris was the quiet fear. Space is mostly empty, but mostly leaves room for trouble. A grain traveling at thousands of miles per hour has no kindness in it. Armor would weigh too much. Luck would have to carry some of the load. The most important organs were tucked behind panels. Trajectories threaded through regions where the statistical odds said the dust would be thinner. Every survived day was a small, grateful nod. The analog heart of the mission is part of its charm. Commands arrived as strings of binary little trains of ones and zeros clicking through the radios, unfolding into actions after long, empty miles. Images didn't splash onto screens. They came as strips and lines, each one a careful gift, assembled into a whole, the way quiet people assemble a quilt. It was slow. It worked. It still works. The slowness felt right for the distances involved, a tempo that matched the music of orbits. What makes this engineering feel tender isn't just the longevity. It's the way the team met the limits of their tools with imagination and care. No smartphones, no cloud to lean on, no glossy three-dimensional modeling like we have now. There were pencils and paper, punch cards slipping into readers with a soft rush, oscilloscopes blinking their green cursive, soldering irons warming fingertips through gloves. Out of that came two machines that can still introduce themselves across a gulf wider than easy metaphor, still compare notes about particles and fields, still send home a weather report from the borderland where the sun grows thin. As the years lengthened, choices grew more intimate. Power faded. Instruments took turns sleeping. Heaters were rationed like tea on a long winter. A camera might be quieted forever, so a magnetometer could keep feeling for the interstellar breeze. Each decision carried the same promise as the first design sketches: make the craft last, keep the science honest. The voices from the edge grew fainter, but not less true. What arrived was often only a whisper shaped like numbers, yet inside those numbers lived storms bigger than continents, rings that are mostly ice and partly poetry, moons with hidden seas, and finally the tremor of crossing the heliopause, the place where home, as the sun defines it, ends. There is a kindness in the way the Voyagers were taught to behave when confused. If something felt wrong, they were to stop, turn their faces toward Earth, and wait. No panic, no thrashing, just a patient request for advice from the tiny speck that sent them. As the round-trip light time stretched from hours toward a day, that patience became a virtue. It is hard to hurry when light is your messenger. Every nut, every bolt, every line of code was a vote for the idea that exploration matters, even when no crowd is watching a design not flashy, but faithful, not loud, but enduring, trusted to carry our questions farther than we could go ourselves. Decade by decade, the power dims, and still the travelers hum on, crossing a darkness full of quiet details. They are older now. They creak a little. They have not stopped listening. They have not stopped telling us what they hear. And that temperament, the calm, the steadiness, was there from the first intention before the fairings ever opened. Late summer held its breath over Florida in 1977, the air warm and salt-tinged, the horizon bright as polished steel. On two separate pads stood a pair of identical travelers, folded and quiet, more like instruments than machines, more like intentions than hardware. Their bodies matched piece for piece, their hearts tuned to the same patient rhythm. Go to the giant planets, look closely, learn what you can, and if fortune holds, keep going. Their names were Voyager 1 and Voyager 2, twins by design, different by destiny. The numbering invites a guess that never quite lands. You might expect the one called 1 to go first, to claim the first arc of exhaust and the first taste of black. Space has its own logic. Voyager 2 rose first, on the 20th of August, 1977. A white flare curling into sky, and then into silence. 16 days later, on September 5, Voyager 1 followed, the second launch aimed at an earlier arrival. The labels were chosen not for order of departure, but for order of arrival at the first giants. Voyager 1's path would thread a faster curve to Jupiter and then Saturn. Voyager 2 would take the longer, more intricate trail, a route with room for more worlds if time and luck allowed. The audacity of the plan lives in its geometry. This was never a simple there and back. The twins were meant to skim past one world and borrow a little of its motion, then aim for the next, then the next, like careful stones skipping across deep water. The trick has a plain name, gravity assist, but it feels like sleight of hand the first time you see it drawn. Once every century and a half or so, the outer planets fall into a rare pattern that opens a corridor. Jupiter, then Saturn, then Uranus, then Neptune, each placed so that the pull of one could fling a craft toward the next with an extra measure of speed. It is a brief window, a secret passage the solar system offers with a shrug and then closes again for generations. Imagine reaching for a moving train and letting it swing you around so you leave in a new direction, faster than you arrived. The train hardly notices. Its weight and motion are too vast. That is what the Voyagers did, again and again. Falling into a planet's gravity well, they sped up. Bending around the world's far side, they left with a new heading and a richer pace relative to the Sunday. Fuel stayed mostly quiet. Physics did the heavy lifting. Without those assists, the journey would have been impractical, a fuel tank pretending to be a spacecraft. With them, the path became elegant, almost thrifty. Timing was the hard law. Launch too early, and the door would not have fully opened. Launch too late, and the handle would slip from your fingers. Each trajectory depended on the planet ahead being exactly where the calculations promised it would be, months or years later, and on the spacecraft arriving within narrow bounds of angle and speed. A small error at Jupiter would bloom into a miss at Saturn. A miss at Saturn would erase Uranus. Without Uranus, Neptune would retreat to a blue dot forever. The navigation teams worked with fractions of a degree, with timing measured in heartbeats spread across months. There would be no joystick nudges once the dances began, only sequences planned far in advance and loaded into memory like a careful piece of choreography. The twins were, in a sense, very patient letters mailed to moving addresses. Voyager 2's route was the longer sentence, with commas and clauses and room at the end for the outermost giants if the ink didn't run dry. To make all that possible, it needed to leave first, lean into a wider arc, and keep its options open. Voyager 1's mission was built for an earlier payoff. Swift arrivals at Jupiter and Saturn, heavy science early, a sharper turn after the ringed world. The paths parted at Saturn, and each choice carried a different promise. Voyager 1 took a steep northern pitch out of the plane of the planets, rising above the sun's thin disk, the way a bird lifts from a river into open air. Voyager 2 held closer to the plane, steady and stubborn, with Uranus and Neptune aligned ahead like cool blue milestones. Together, the pair turned exploration into a relay, one handing off knowledge to the other, filling in the map with different angles and tempos. The launches themselves did not shout for attention. There were no astronauts waving, no primetime broadcasts replayed on every screen. Each rocket was a Titan 3IE, with a Centaur upper stage, a stack of controlled thunder designed to do a single, beautiful thing: lift the travelers clear of Earth's gravity well and give them the speed they would need to meet their first appointment on time. Voyager 2 had a brief moment of worry in its upper stage telemetry, a stutter in the data that tightened throats in the control room, but the spacecraft steadied and sailed on. Voyager 1's ascent felt like the illustration in a textbook: clean, on time, precise. Within hours, both craft were settled into long arcs that pointed away from home and toward the waiting giants. From the moment the fairings opened and the twins felt vacuum on their skins, the plan unfurled exactly as it needed to. The gravity highway is not a true road. It is a promise disguised as math. To keep it, the Voyagers had to be unhurried and exact. Long before each encounter, teams on Earth shaped command sequences that would tell a camera when to blink, a spectrometer when to look, an antenna when to turn its face toward the deep. Because the round-trip time for a conversation stretched by the day, the choreography had to be right without last-minute whispers. Each sequence was a quiet deal made in advance with physics. Here's where we'll be. Here's how we'll look. Here's what we'll try to notice as we pass. The gravity assists were never just tickets to the next stop. Each pass by a planet opened a window for wonder moons lit like lanterns in the dark, storms that seemed to breathe, rings that revealed themselves as lace made of ice. To capture any of it, the spacecraft had to pivot delicately while rushing faster than any airplane had ever flown, then settle back into a precise orientation to send the data home through a signal so faint it could hide inside noise. Success depended on patience at both ends, the craft keeping its composure, the deep space network listening without blinking. As Voyager 1 pulled ahead, it became clear that it would not linger for Uranus or Neptune. The steep deflection at Saturn put it on a high-latitude course, leaving the planetary plane behind and heading toward the space above the sun's bright disk. Voyager 2, slower but persistent, kept faith with the longer road. It would become the only visitor to all 4 outer planets, a quiet record, kept not in trophies, but in pictures and measurements, and the cadence of a healthy heartbeat sent from far away. None of that was guaranteed when the rockets roared. The official promise reached only to Jupiter and Saturn. Anything beyond was a gift the future might or might not bring. It's easy to imagine the control rooms as tense and loud, but most of the work felt like breath held just so. Navigators tuned numbers that could have been music. Engineers watched the twins' temperatures, their voltages, their orientation in the wide dark. Planners counted down to encounters with calendars layered over calendars, each box filled with instructions that would unspool days later at precisely the right second. Somewhere in those rooms, someone would glance at the wall clock and then at the chart of one more tiny mid-course correction. The difference between being a few hundred kilometers left or right of a point in space where left and right hardly mean anything and still mean everything. The elegance of gravity assist is kinder than its name suggests. It's not a slap, it's a turn, a borrowed cadence. The planet gives a whisper of its orbital momentum to the passing craft, indifferent and generous at once. The craft leaves with more speed relative to the sun, and a new aim, carrying a pocketful of observations as it goes. The planet continues almost unchanged, too massive to feel what it has given away. In that exchange is a philosophy. You go farther by listening to the place you pass, by adjusting to its pull rather than fighting it, by taking what's freely offered and spending it well. What began at Cape Canaveral didn't ask for a parade. The liftoffs were clean, the telemetry settled, the math held. 2 machines inhaled the last touch of Earth and exhaled into orbits that would carry them past the familiar and into the cool light beyond. If the crowds were smaller than in Apollo's days, the meaning was not. This was a venture that would take decades to unfold, measured in patient postcards and gentle course changes, in signals growing fainter year by year and somehow more intimate for it. Months became years, and the first promises were kept. Jupiter's gravity pulled, turned, and released each craft with a blessing of speed. Saturn did the same. And with that parting touch, the twins diverged into their different futures. They rode a corridor opened by a rare alignment that appears only once in about 175 years. An invitation slipped under the door of a century, and someone circled dates on a calendar and said, yes. Out there, the solar system proved less a flat diagram than a moving conversation. Planets swinging and shining, fields stretching and folding, small travelers borrowing momentum without harm. The launches in 1977 were quiet, but the boldness ran deep, a belief that careful timing, gravity's soft hand, and steady attention could carry us to places we had only guessed at. Then, right on cue, the first view that warranted a held breath began to swell in the frame. Jupiter had always been the bright lantern at the far end of the neighborhood, striped and stately, a mystery that seemed content to remain one. Through telescopes, it looked composed bands laid down like careful brushstrokes, a coral oval drifting by like a memory. As the Voyagers drew near, that calm face began to move. Quiet from afar, turned into weather with a heartbeat. In March of 1979, Voyager 1 slipped to within about 350,000 miles of the cloud tops, roughly the distance from Earth to our moon, a small machine that had crossed 500 million miles, now brushing past a world more than 11 Earths wide and over 300 Earths in mass. In July, Voyager 2 followed the same road, a few months behind, patient and alert. Together they traded the blur of an old painting for the texture of living air. The first surprise was how busy the planet is. Those tidy belts and zones were not ribbons on a gift, they were conveyor belts, roaring in opposite directions. Ovals, the size of continents, spun like tops, rose and sank, merged and parted. The great red spot, long seen as a single mark through dim optics, came alive. It wasn't simply red, it was layered, textured, almost braided, a counterclockwise storm big enough to swallow Earth and still not feel full. Ammonia clouds rolled and sheared along its rim, while unknown chemistry lent it color, a rusty blush shifting across time. And there were many more storms, dozens of smaller eyes and eddies moving in choreography too complex to untie at a glance. Jupiter's spin is part of the engine. A Jovian day is less than 10 hours, a world that enormous, turning faster than a city carousel. The speed stretches the atmosphere into bands. The bands shear against each other. The shearing breeds storms that can outlive empires. Beneath the cloud decks lies an ocean of hydrogen and helium, pressure squeezing gas towards something that behaves like liquid metal, heat flowing outward to feed the weather from below, while the sun paints from above. Calm, from a distance, is just a scale trick. Then the company Jupiter keeps began to crowd the frame. The planet is not a solitary giant. It is a small solar system of its own, with moons large enough to be worlds and small ones that dart like sparks. Astronomers expected scars and ice, familiar craters and quiet plains. The cameras found drama. Io stepped into view first and stole the scene. Voyager 1's images showed plumes blooming from the surface, tall, thin curtains arcing hundreds of miles high, so big they cast their own shadows on the world below. Not frost, not dust. Volcanoes, active and loud, the first ever seen beyond Earth. The surface was a splashed palette of sulfur and basalt, yellows and reds and umbers spread over lava plains still warm from the night before. Fresh flows cut across older ones. Calderas gaped like open mouths. It looked like a place that could not sit still. The engine behind that restlessness is tidal heating. Io is squeezed in a three-body tug, Jupiter on one side, Europa and Ganymede pulling in time on the other. The moon's interior flexes and relaxes with every lap, rock grinding rock into heat, like bending a paperclip until your fingers feel the warmth. Melt rises, eruptions follow, the surface is repaved. Earth's moon reflects sunlight with perfect poise. Io flings fire in reply. Europa drifted in next, pale and reserved, almost shy by comparison. Few craters, long lines crossing like strikes of ink, whole swaths as smooth as frozen breath. Smoothness in space whispers of renewal. The dark lines were not canyons in stone, but fractures in ice, signatures of plates that drift and refreeze, of slabs that crack and slide and then seal again. The pattern hinted that the ice floats on something softer and deeper, a global ocean, salty and dark, kept liquid by the same gentle squeezing that torments Io. Beneath miles of ice, water could roll and tide, touching a rocky seafloor. Where water meets rock and warmth, chemistry rarely sleeps. Europa's quiet face became a possibility, a place where life might drift without sunlight, taking its cues from vents and minerals and the patience of time. Ganymede arrived large enough to reset assumptions. Bigger than Mercury, it wears the crown for largest moon in the solar system, and Voyager traced grooves and lanes across its crust that looked like the scars of old rearrangements. Hints of a magnetic field stirred in the data, something no other moon had shown, suggesting a mysterious interior that knows how to move charge around. Callisto followed like an elder, ancient and cratered to the edge of endurance, a mosaic of old impacts so dense that new craters would sometimes erase the memory of older ones. If Ganymede looked like a world that had tried things and changed, Callisto looked like a world that had seen everything and kept the record. Turning back to the giant itself, the spacecraft listened for the reach of Jupiter's magnetosphere, the bubble carved out by its magnetic field. Strong doesn't begin to cover it. The field is about 20,000 times Earth's strength, a spinning dynamo that traps charged particles and builds radiation belts with teeth. Voyager carried shielding like a coat against winter, enough to withstand the brief onrush without frying its thoughts. If that magnetosphere were visible, it would sprawl wider than the full moon in our sky, a ghostly umbrella of particles and fields trailing millions of miles downstream along the poles. Spiraling particles rained into the atmosphere and painted auroras, cousins to our northern and southern lights, but bigger and wilder, their curtains billowing with the breath of a giant. Another surprise hid in the planet's shadow. Rings faint, dusty, almost not there, but real. They weren't the screaming brightness of Saturn's broad bands, but a thin veil of fine particles, likely knocked off small inner moons by micrometeorite strikes. Enough dust rises, enough dust lingers. What had been an assumption that Saturn alone wears rings worth noticing softened into a wider truth. Rings are a habit the outer worlds share, each in its own way. All of this unfolded 500 million miles from the place that built the machines, carried home by transmitters the size of a fruit and computers that would blush sitting beside a modern phone. The images came in lines and blocks, patient as rain filling a barrel. Grainy, yes, but grainy like a charcoal drawing full of tone and texture. a storm the size of a planet, a moon painting with lava, a second moon drawing calligraphy in ice. It was enough to keep tired eyes awake a few minutes longer, to make the distance feel less like a wall and more like a long hallway. The numbers mattered, and they landed gently. March 1979 for Voyager 1's closest kiss, July for Voyager 2. A closest approach of about 350,000 miles, so near that you could measure it in familiar terms, the Earth-Moon gap. A day on Jupiter shorter than our workday, less than 10 hours for a world that could hold 1,000 Earths. A magnetic field some 20,000 times stronger than our own, bending space in a way that made auroras roar. 11 Earths side by side would just span its equator. More than 300 Earths' mass would barely fill its gravitational hand. The scale became a lullaby with big numbers instead of notes. Science did not stand off to the side while the gravity assists did their work. Each flyby was a festival of attention. Long before the encounters, teams on Earth wrote command sequences like choreography, telling the cameras exactly when to look, telling spectrometers when to taste, telling the antenna when to turn toward home and speak. Round-trip light time stretched. The dance had to be right from the start. The spacecraft pivoted with care as they rushed by, then steadied, then listened for Earth with the patience of old friends waiting their turn to talk. By the end of those months, Jupiter had stepped down from its pedestal. It was no longer a striped abstraction but a weather world with an interior life, a magnet that shaped space around it, a ring bearer, and the anchor of a family of moons that could have filled a decade's worth of missions all by themselves. The surprises did not contradict what had been suspected. They outgrew it. Volcanoes blowing in vacuum, oceans hidden under ice, moons with magnetic hearts, moons that wear their age openly. The planet's storms were not pictures of storms. They were storms, moving and changing while we watched. What the Voyagers carried back was more than data points. They brought intimacy. They took a place we had watched all our lives and let us feel the wind on it. Numbers that meant wind, colors that meant chemistry, lines that meant fracture and flow. They asked Jupiter questions we hadn't known how to form and returned answers wrapped in more questions, the kind that keep a mind awake in the best way. When the lantern of that world had been turned in their hands and new gleams marked for later study, they let Jupiter's gravity pull on them one last time, a gentle hand at the elbow bending their paths toward the dim light ahead, where Saturn waited like a quiet stage already lit, elegant where Jupiter was theatrical, pale gold where Jupiter flared. Even those who never thought about orbits knew its outline. Long before cameras could do it justice, a small telescope gave Galileo a hint, and he guessed at ears flanking a planet he could not quite resolve. Better glass and patient eyes turned those ears into rings broad, impossible, so thin they seemed like tricks of vision. Posters and book covers tried to hold the balance of it, but none of them could prepare a person for the first close look that arrived when the Voyagers slipped into range and began to send their careful lines of pixels home. Voyager 1 came first to the ringed world in November 1980, gliding to within about 77,000 miles of the cloud tops. Less than a year later, in August 1981, Voyager 2 traced an even tighter curve. Together they gave Saturn back to us in detail. The planet not as a symbol, but as weather and shadow, structure and surprise. The rings were the first astonishment, even for people who had expected to be astonished. Mostly water ice, from grains like snow to chunks as large as houses. The main rings stretched for more than 200,000 miles across, and yet were often no thicker than about 30 feet, like laying a sheet of paper over a football stadium and having it hold its shape. What had once looked like a few broad bands opened into a lacework of thousands of ringlets, each one responding to gravity's soft tugs. Gaps appeared where there should have been none. Waves rippled through narrow lanes. Edges stayed unnaturally sharp, as if tended by a careful hand. The famous Cassini division, the dark lane between the A and B rings, visible through backyard telescopes for generations, refused to be empty when the cameras looked closely. It held its own filigree of thin, faint rings, subtle as breath on glass. Deeper in the A-ring yawned a narrow fissure, the Encke Gap, a clean line drawn by small shepherd moons whose gravity did the work of gardeners. Prometheus and Pandora, and others like them, nudged particles back into place, corralling and sculpting with touches so light they might as well have been whispers. Then there were the spokes. They drifted like ghostly radial shadows across the bright ice, appearing and fading, sliding along with the planet's magnetic rhythm. The cause was, and remains, a puzzle with multiple keys, charged dust lifting in Saturn's rotating magnetic field, tiny impacts stirring clouds that briefly hover. Whatever their source, they lent the rings an ethereal, living look, as if a hand had just brushed a fingertip across the record grooves of a cosmic turntable. Saturn itself wore subtler colors than Jupiter, but subtle does not mean still. A day there runs just over 10 hours, and that quick spin pulled cloud bands into flowing lanes that wrapped the globe. Jet streams threaded those lanes. Beige and butterscotch hues folded into one another like layers of silk. Large storms swelled and faded. Near the poles, geometry took a strange, mesmerizing turn. Voyager's glimpses hinted at a hexagon, a six-sided pattern etched by winds around the North Pole, a curiosity that would be seen in striking detail decades later by the Cassini orbiter. Even without the full portrait, the outlines were enough to suggest that Saturn's atmosphere holds shapes as well as currents, harmonies as well as noise. Drifting a little farther from the planet's glow, the moons gathered like a chorus. Some were small and skittish, some old and scarred, some bright as fresh snow. One in particular changed the course of the journey. Titan loomed largest, bigger than Mercury, wrapped in a thick orange haze. Instruments tasted the atmosphere and found mostly nitrogen, with methane and other hydrocarbons woven through a composition more akin to Earth's air than anything else the travelers had met. Pressure at the surface seemed substantial. Chemistry bristled with possibility, but the haze was a curtain, and Voyager's cameras could not see through. The surface stayed private, its shapes hidden, its stories implied. Weather might be sculpting that world. Erosion might be at work. Lakes or seas might sit in the cold, waiting. The questions were heavy enough to bend a trajectory. To honor Titan's promise, Voyager 1 took a path that swung close for a better look, and then lifted out of the plane of the solar system, entirely an elegant, deliberate turn that ended its chance to meet Uranus and Neptune. The choice was gentle and final at once. Voyager 2 kept to the wide, flat lane, reserving its strength for the farther giants. Two twins, two fates, both honest to the mission's heart. Listen closely to what you pass. Let what you learn shape the next step. The rest of Saturn's family stepped in with their own accents. Mimas, pocked by a vast crater, looked for all the world like fiction come true, its face recalling a famous movie moon with a single dark eye. Tethys and Dione glimmered with bright ice, their surfaces cut by cliffs and valleys that hinted at old tectonic strains. Enceladus shone almost painfully white, a tiny world so reflective it looked newly fallen. No one yet knew about the geysers that would be seen later, about the subsurface ocean that would become one of the solar system's most whispered about secrets, but the brightness itself suggested youth and renewal, a surface repainted more often than the crater count could keep up with. Rhea drifted by in grays and creams, old and quiet. Iapetus, half bright and half dark, kept its mystery for another day. Saturn's magnetosphere lay around all of this like a soft glowing shell, gentler than Jupiter's fierce trap, but still vast, still capable of catching charged particles and guiding them along magnetic field lines toward the poles. There, auroras flared cousins of our northern and southern lights, drawn out into long, shimmering curtains by a planet's electric heart. The Voyagers felt the fields and counted the particles, turning invisible architecture into notes on a page. The numbers were calm, the picture they composed was wide. The choreography of the flybys demanded a kind of patience that matched the world they were visiting. Long before the encounters, teams on Earth wove command sequences that told each instrument when to wake, which angle to hold, when to steal a glance back at the rings, when to look away and study a moon's limb for a few stolen seconds. Light time stretched. The dances had to be set well in advance. The spacecraft pivoted and paused, took their measures, then turned their dishes toward home and whispered what they had seen at power levels so faint a snowstorm of radio noise could almost hide them. The Deep Space Network listened with the steadiness of hills. For all its calm, Saturn still surprised. The ring's unbelievable thinness held even at close range. Their edges stayed sharp, not by magic, but by a mesh of resonances and shepherding, a gravity conversation conducted by objects so small you could miss them in a careless glance. The Cassini division refused to be a void. The spokes skated where no shadows should have been. Titan's atmosphere was thick and real, and it was mostly nitrogen, and it remained stubbornly opaque. The planet's own winds wrote soft music in fast time. The polar hexagon hinted at an atmospheric geometry that does not tire. Nothing contradicted what had been suspected. Everything deepened it. There was a small tenderness in the way the Voyagers completed this part of their work. These were machines born in an age of shag carpet and microwaves new to the kitchen, carrying cameras with less resolution than a pocket phone would boast later on. The computers aboard had what, by today's measure, would seem like a handful of memory. Yet, they aimed, exposed, corrected, aimed again, and survived the passages through radiation and shadow. The pictures that arrived were grainy, only in the way good charcoal sketches are grainy, full of mood and shape, precise where they needed to be, generous where wonder could safely fill the gaps. When the business at Saturn was done, choices settled into place. Voyager 1, after the Titan encounter, tilted northward above the solar system's disk, its planetary tour complete, its long cruise into interstellar space begun in earnest. Voyager 2 set its sights on the distant blue worlds and kept going. Behind them, Saturn remained in the mind, not just as a planet, but as a neighborhood, rings that behave like a living fabric, moons that keep secrets in ice, a haze that hides an entire landscape while inviting guesses, a polar wind pattern willing to hold a hexagon steady against time. Numbers lingered softly like notes. 77,000 miles at closest approach for the first visitor. The year 1981 for the second close pass. A day a little over 10 hours long. A ring system more than 200,000 miles wide and yet thinner than a modest house is tall. None of these facts raised a voice. They only made the image clearer. Beauty in the outer solar system is not just force and heat. It is arrangement, resonance, balance, the grace of particles finding their places and staying there for a while. What the travelers offered was intimacy without intrusion. No touchdowns, no drills, no roaring engines near fragile ice. Just flying by with attention and care, letting gravity bend the path and timing do the rest. In the pictures and fields and spectra, a distant emblem became part of our ordinary knowing. The rings were no longer an idea. They were a place where sunlight turns to glitter and shadows to geometry. The moons were not list items, they were characters. And the planet, wrapped in its thin golds and wrapped again in ice and again in magnetic field, took its place not as a postcard, but as a chapter, written in a hand steady enough to carry on. By the mid-1980 seconds, the long arc of Voyager 2 had already gathered Jupiter's thunder and Saturn's grace, like stories tucked into a coat pocket. That would have been enough to earn a quiet legend. But the corridor opened by that rare alignment still ran outward, and the little craft kept its promise to follow it toward the cold blue ends of the family portrait, the ice giants that most of us knew only as distant, tidy dots. No other spacecraft had stood beside them. None has returned since. Voyager 2 remains the single witness, the one pair of eyes that went and looked. Uranus came first, a January 1986 rendezvous with the seventh planet from the Sunday. At arm's length through telescopes, Uranus had always looked simple, pale, turquoise, nearly featureless, an even wash of color like a planet sketched with a single crayon. Up close, the stillness loosened and revealed seams. The most unsettling truth was geometric. Uranus is tipped over. Most worlds spin like tops, leaning a little, correcting a little, steady in their pride. Uranus lounges on its side, rolling around the sun with an axial tilt of about 98 degrees, as if a colossal hand once bumped it and then left it to think about what happened. Seasons there are long and strange, one pole bathing in daylight for more than 20 years, while the other keeps vigil in shadow, and then, slowly, surely, they trade places. When Voyager 2 visited, the South Pole faced the sun almost directly, a view that clarified some things and hid others, like opening a curtain only halfway. The air was colder than anything measured before, a brisk 370 degrees Fahrenheit, a kind of cold that turns motion into whisper. Faint bands showed through, and hints of wind, modest compared with Jupiter's theatrical weather. Later, with patient analysis, the numbers confessed more. Uranus carries winds that can rush to 500 miles per hour, fast but subtle, muted under a haze of methane and ammonia that smooths the drama into calm. The magnetic field refused to play by familiar rules. Earth's magnetic axis hews close to its spin. Uranus shrugs and points elsewhere. Tilted by nearly 60 degrees and offset from the planet's center, its field sets up a lopsided magnetosphere that wobbles as the world turns, like a bar magnet trying to keep its balance on a rolling barrel. It is not wrong. It is simply different, and difference is its own kind of truth. The moons gathered around this tilted planet were not quiet scenery. Voyager 2 discovered 10 new ones, bringing the count at the time to 15, small companions that had hidden in the glare. Among the larger known moons, Miranda stole attention by sheer audacity. It looked patched together, as if someone had built a world out of beautiful leftovers and forgot to sand the edges. Enormous cliffs, ridges that wander, valleys that look torn and restitched, some structures rising on the order of 12 miles high, more than twice the depth of the Grand Canyon if you turned it upside down. Perhaps Miranda was shattered and gathered itself again. Perhaps it convulsed from within, ice and rock shifting until the crust read like a diary written out of order. Whatever the cause, the effect was intimate. Even small worlds can carry complicated histories, written in relief. Uranus has rings too, 9 narrow bands, discovered only in the late 1970 seconds, and confirmed and refined by Voyager's eye. They are dark and spare, made of dust and rock coated with material that reflects little light, so thin they seem to whisper rather than sing. They do not imitate Saturn, they keep their own counsel, faint threads circling a sideways world in cosmic stealth. The path did not pause for long. Between Uranus and the next appointment lay another 5 billion kilometers, more than 30 times the distance between Earth and the Sun, in total reach from home. No pit stops waited there, no mechanics bay in the dark, only a small, aging machine, relying on timing and a steady dish to keep its voice pointed the right way. In August 1989, the craft arrived at Neptune, the farthest planet by classical count, a deep blue globe whose color is born in methane's trick of swallowing red light and letting blue light go. Where Uranus had seemed reserved, Neptune turned its face into the wind. Storms filled the frame. The now famous Great Dark Spot came into view, an oval large enough to stand beside Earth without apology, edged by bright white clouds of frozen methane that looked like high cirrus on a winter afternoon. Winds raced faster than sound up to 1,300 miles per hour, so swift that the usual language of weather starts to stammer. How does a world so far from sunlight feed such motion? The answer is incomplete, even now. Internal heat leaking outward, subtle chemistry trading energy in the cold, Neptune seemed to make music with scant notes and still fill the room. Its magnetic field kept up the ice giant habit of strangeness, tilted, offset, alive with interactions that Voyager could feel as radio emissions and shifting boundaries where solar wind meets planetary breath. The magnetosphere writhed and wobbled with each rotation. If you could hear it, it would sound like a chorus sung in an unfamiliar key that still manages to make you ache. Then Triton, Neptune's largest moon, stepped onto the stage with a quiet that did not last. Its orbit runs backward retrograde opposite the planet's rotation, a sign that it was likely captured rather than borne in place, perhaps a Kuiper Belt wanderer pulled into a cold embrace. Triton is cold, but cold is not the same as still. Voyager 2 watched geysers of nitrogen spurt miles into the thin air, streaking the surface with dark plumes. Cryovolcanism, ice behaving like lava, hinted at inner warmth, maybe from radioactive decay, maybe from the tugging changes in gravity long ago. The surface mixed smooth plains with ridges and odd textures, patterns unlike anything seen elsewhere. And a fragile nitrogen atmosphere drifted above, making Triton one of only 2 large moons we know, with a recognizable envelope of gas, the other being Titan, far back at Saturn. Neptune itself wore rings as well, faint and incomplete, more like arcs and clumps than continuous bands. Voyager 2 discovered 6 new moons there and traced those dusky rings, proving again that the farther you go, the more the familiar rules bend into something nuanced but consistent with itself. The outer solar system is not a place where sameness repeats. It is a place where family resemblance hides under unique faces. By the time the blue planet's pull had done its work and slung the traveler onward, the great tour of planets was complete. From that point, cameras would rest, instruments tuned to fields and particles would keep their long watch. The craft would trade flyby choreography, for a patient drift. Yet the leaving did not feel like an end so much as a change of light. Uranus and Neptune had been promoted from dots to destinations, from names on a chart to worlds with lives. One carried seasons that last decades, and a magnet that ignores the usual alignment, a patchwork moon with cliffs like pages fanned in a book, and narrow, dark rings that hide until you stand very close. The other carried storms with supersonic edges, a tilted, wandering magnetosphere that sang on the radio, a captured moon that breathes nitrogen through cracks in ice, and rings that prefer arcs to circles. All of it was learned by a probe that left Earth when disco was on the radio, and memory was measured in kilobytes. No refueling, no repair. Just gravity, timing, and a willingness to listen for whispers across 1 billion miles of silence. The numbers remain soft in the mind. January 1986, a turquoise world tipped on its side. August 1989, a deeper blue world full of fast weather, a tilt of to 98 degrees. Winds up to 500 miles per hour hiding beneath haze. Winds up to 1,300 miles per hour roaring across a far colder sea. 10 new moons found at Uranus, 6 more at Neptune, rings in the far dark that prefer to be seen out of the corner of the eye. What Voyager 2 did out there was more than extend a checklist. It widened the idea of possible. It showed that the planets we rarely name first are not footnotes, but chapters with their own cadence and color, chapters that change how the whole book reads. It proved that even places with little sunlight can carry weather that moves like purpose, that even small moons can be dramatic, that magnetism out at the edge can draw new shapes on space. And it did so by arriving on time, staying humble, and letting the worlds tell their own stories while it drifted, unhurried, to the next line in the sky. Long before playlists could follow you into the shower, and videos could cross a planet in an afternoon, we packed a mixtape for the dark, not for ourselves, but for whoever or whatever might someday pick it up. 2 copies, bolted to 2 small travelers, each one a 12-inch gold-plated copper record tucked inside an aluminum jacket with a stylus and a set of patient instructions etched on the cover. It sounds like something from a tender science fiction story, and yet it is simply true. The golden record sailed with both Voyagers, not as a beacon, not as an alarm, but as a greeting offered to the long future. The idea took root with a small, bright group led by astronomer Carl Sagan. The spacecraft were already doing something audacious, skimming past the giant planets and then coasting toward the edge of the sun's domain. If they were going to leave the neighborhood entirely, why let them go empty-handed? The odds that anyone would find a record strapped to a passing probe are microscopic. The galaxy is vast, the Voyagers small, interstellar space, mostly patient silence, but the point was never probability. The point was posture. If you are going to step into the unknown, carry a hello. Time was short, months, not years. The team set about choosing what could stand in for a world, knowing full well that no hour of sound and handful of images could be everything. They worked quickly and carefully, part engineers, part curators, part poets, laughing now and then at the strangeness of building a gift for an audience that might not have ears, eyes, or music at all. Still, they filled the grooves with care. First came the greetings, spoken messages in 55 languages, from ancient Akkadian to modern dialects like Wu. Some sounded ceremonial, others informal, the kind of friendliness you use at a front door. One small voice says, "Hello from the children of planet Earth," simple as a handprint. Alongside the words went the sounds of home. Surf and wind, thunder, birds calling, a heartbeat, a kiss, footsteps, a train, the airy sigh of a Saturn V lifting itself from the Cape. Laughter made the cut. So did the long, yearning song of a humpback whale, a voice that carries even when you don't share a grammar. Then the music. It really is a mixtape, not of favorites, but of range 90 minutes, to say we can keep time in many ways. Bach's Brandenburg, bright and intricate, sits near Javanese gamelan, bells and bronze washing like rain on stone. A Navajo night chant, a shakuhachi piece from Japan, a Peruvian wedding song, Louis Armstrong's Melancholy Blues with its late-night hush. Blind Willie Johnson's Dark Was the Night, Cold Was the Ground, wordless and human in a way that makes the chest ache. Carl Sagan once said, "That song expressed the condition of being human better than any line of text could." He had a point. Sometimes meaning travels best without syllables. The Beatles hoped to include Here Comes the Sun, but permission knotted itself into a no. Even A Gift for the Stars finds the edge of a contract. The record did not sulk. It turned its face to other songs. Sound alone would have been a kindness. The team wanted pictures too. They encoded 116 images in analog signals. A spiral of instructions becomes a frame, and then another, until a visual story assembles itself in a stranger's hands. Landscapes, animals, a newborn small and new pink, a mother nursing, people eating, dancing, working, hands making and sharing food. There is a photograph of Earth from space, a blue and white punctuation mark. There are diagrams, a map drawn in pulsars and timing that says, without words, this is where we were when we let this go. Hydrogen's spectral fingerprint, the structure of DNA, units that lean on constants instead of culture. If someone ever decodes the images, they could piece together a rough sense of us, our size, our shape, our place, our curiosity. One of the most intimate inclusions is invisible unless you know where to listen. An hour of brain activity from Anne Druyan, a member of the team who would later marry Sagan. Electrodes traced her thoughts while she meditated on history and hope, on what it means to be human, and, famously, on the fact that she had just fallen in love. That pattern was translated into audio and tucked into the record's grooves. Somewhere in the dark, her neural music travels with the whales and Bach, a private constellation given a quiet orbit. Because you can't assume familiarity with needles and cartridges, the cover carries a map and a manual of sorts, symbolic drawings that show how to assemble the stylus, how fast to spin the disc, where to put the pickup, how the images are to be reconstructed from the signal. It's almost playful, an IKEA sheet for the cosmos, but written in the sober language of physics, ticks of hydrogen, positions of pulsars, ratios that won't change if calendars do. The same map that offers a lesson in finding us has sparked a joke or two about advertising our address. Sagan's answer was steady. Any beings capable of intercepting a record in interstellar space would already have the means and the judgment to decide their approach. This wasn't a flare. It was a card tucked in a book, saying only that we were here and tried to be kind. 2 copies flew, one with each Voyager, each record wrapped against micrometeorites by its aluminum sleeve, each accompanied by a cartridge and needle, each with a small quantity of uranium, 238, electroplated onto the surface, so a future listener could, in principle, carbon date the gift by half-lives. They are the most distant human artifacts in existence, a pair of slow-turning greetings bound to craft that outlived their warranties many times over. The records do not broadcast. They don't shine or beep. They ride quietly, ready. If nothing ever hears them, they will still have been worth assembling, because they changed how we carry ourselves into the dark. It's easy to call the project romantic and stop there. It is romantic, in the best way, a refusal to let usefulness be the only measure. But the record also does a practical thing. It reminds us that exploration is not just catalogs of rock and radiation belts. It is also culture, feeling, context. The way we hold a baby or a violin, the way we watch clouds, the way our mathematics leans on patterns we hope are universal. The selection was never perfect. How could it be? No hour of sound contains a planet. Still, the choices say we tried to balance clarity and warmth, science and song. We tried to be honest. The list of contents reads like a weather report from our species at a particular hour. Greetings offered with varied cadences, waves from many shores, instruments that clatter and ring, voices that waver and soar, images of fields and cities, cells and stars. A map to us, not to lure or to warn, but to admit we are somewhere, we are particular, we have a home. The curation says something else, too, that knowing is not just measuring, it is also sharing. The record is a way of holding the door and saying, if you are out there, here is what it felt like to be us. The gesture has carried farther than any parade ever could. Right now, billions of miles from here, the two small disks travel with the patience of stone. They will outlast the ships that bear them. They will outlast the languages they carry. They might outlast the continents as we arrange them now. Perhaps no one will ever pick one up and follow the etched instructions, count the ticks of hydrogen, assemble the needle, and listen to a whale. That's all right. The bottle was cast into the ocean anyway, as Sagan liked to say, because bottles and oceans are how you think when you love a shoreline you are about to leave. Somewhere past the heliopause, where the sun is no longer a wind, but a faint memory of warmth, a golden record turns. It is not busy. It is not necessary. It is an act of manners. It says we lived on a water world that spun in light. We learned to count and to sing. We listened to thunder and to each other. We drew maps and babies and birds. We sweated and argued and tried for grace. We looked up. We wondered. We said hello. When the two Voyagers left in 1977, our picture of the solar system was a tidy sketch. A few close-ups from earlier missions, a library of telescopic glimpses, and a scaffolding of informed guesses. The outer giants sat at the edge of that sketch like distant mountains, huge, cold, and largely theoretical. The twins did more than sharpen the lines. They turned questions into places. They gave moons personalities, rings, histories, atmospheres, weather, magnetospheres, tempers. The diagram became a family album. The moons, especially, stepped forward. We had expected airless pebbles and cratered ghosts. Instead, we met worlds in the middle of something. At Jupiter, Io erupted into the record with fountains of sulfur and ash, true volcanoes, alive and loud, throwing plumes hundreds of miles high. No one had seen such a thing beyond Earth. Its skin wore yellows and reds like a fever, freshly painted by flows that cooled only to be overlaid again. Beside that heat, Europa looked composed, pale, etched with long, dark lines and crossings like scratches on ice. Those fractures suggested an outer shell that moves and heals, plates that shift and refreeze. Beneath the shell, tides from Jupiter's pull may keep a deep ocean liquid, water and rock, exchanging hints and heat in a darkness where chemistry has time to think. After a single flyby, Europa changed categories from moon to possible habitat, a quiet world with a secret sea. Around Saturn, the story remained gentle and surprising. Enceladus gleamed like new snow, so bright it hurt to look at in raw images. Its surface seemed young, undersupplied with craters, as though someone kept repaving it. The Voyagers couldn't see the geysers that a later mission would catch in the act, but the clues were there, like footprints on a porch after a snowfall. Titan kept its face hidden behind an orange haze and became more interesting for it. Instruments felt the pressure and tasted the chemistry and atmosphere thicker than Earth's, mostly nitrogen with methane and complex organics threaded through. A moon with air, weather, and the raw ingredients for prebiotic play. A laboratory wrapped in cloud. Farther out, Uranus and Neptune extended the lesson. A small Uranian moon named Miranda looked broken and remade. Canyons and blocks, cliffs that tower some dozen miles, terrain stitched together from patterns that didn't quite match. It felt like a chapter torn from a longer book and glued back in out of order. At Neptune, Triton ran counter to the planet's spin, a sign of capture from the Kuiper Belt, and yet it breathed. Voyager 2 saw geysers of nitrogen rise into a thin sky and fall again as dark streaks, cryovolcanism in the deep cold. In one pass, a large moon became a place with weather and a past. The planets themselves shed their old masks. Jupiter's atmosphere, once a set of elegant colored belts, came alive as a machine of weather, jet streams racing in opposite directions, storms sprouting and merging. The great red spot revealed not as a static emblem but a living vortex with structure that changes while you watch. Saturn, a quieter gold, still carried bands and storms, lightning tucked inside clouds, auroras flickering along field lines near the poles. The planet's quick spin flattened its curves at the top and bottom. The cameras caught the shape, and the numbers filled in the physics. Those famous rings stepped forward from symbol to phenomenon. Where we had imagined a handful of wide bands, the images teased out thousands of ringlets, edges so sharp they looked cut with a blade, waves and gaps caused by the tug and tap of small moons. The Cassini division refused to be empty. Faint strands ran through it. Spokes appeared ghostly, radial streaks crossing the rings like moving shadows, signatures of charged dust dancing with Saturn's rotating magnetic field. Tiny shepherd moons worked the edges, sweeping particles into clean lines the way a careful hand smooths flour on a board. Rings turned out not to be Saturn's private habit. Jupiter wears a thin, dusty veil. Uranus keeps narrow, dark hoops. Neptune's rings break into clumpy arcs, as if halfway between order and drift. Before, one planet was the ring-bearer. After, rings felt like a family trait expressed in different ways. Magnetism gave each world its own weather in space. The Voyagers carried magnetometers, delicate compasses, that could feel the shape of an invisible room, and learned that Jupiter's field stretches for millions of miles, trapping particles in belts of radiation far harsher than any near Earth. It is a place of currents and shocks, a wind lane where charged particles sing. Saturn's field, closer to aligned with its spin, still had strength to guide auroras and whisper across the rings. Out at the ice giants, the script flipped. Both Uranus and Neptune hide dynamos that are tilted and offset, producing magnetospheres that wobble as the planets turn. A lurching choreography that forced new thinking about how fields are made, how rotation, internal structure, and convection combine in ways more varied than the textbook examples. The instruments wrote the rest of the notes. Spectrometers and infrared sensors read temperature, cloud height, and composition, hydrogen and helium dominant in giants, methane painting the blues, trace gases sketching the chemistry of light and heat. Gravity measurements added their quiet constraints, tiny variations in speed and path that mapped how mass lies inside. Plasma detectors felt the solar wind's handshake with each magnetosphere, boundaries shifting like curtains in a draft. From these threads, thousands of papers grew, some quick and bright, some slow and deep, many still ongoing long after the pictures stopped coming. And more moons, scores of them, joined the roll call. The counts doubled and kept climbing. Catalogs turned into conversations. This one resonant with that one. This one resurfaced. That one left old scars untouched. A satellite ceased to be a footnote. It became a world with time's handwriting on it. All of this from machines with memories measured in kilobytes, with moving parts you could name without acronyms, with tape recorders and analog hearts. The elegance was in the fit. Instruments chosen to say a lot with little, power managed like a winter pantry, commands choreographed months ahead, because light itself would take hours to carry a question, and hours more to bring the answer back. The Voyagers were not clever because they were new. They were wise because they were simple and steady. What they revealed most clearly wasn't a single storm or moon. It was complexity as the rule. The outer system is not a quiet attic stuffed with gas balls and ice rocks. It is busy, layered, restless. Weather, tides, fractures, dynamos, rings that hum with resonance, everything interacting at timescales that stretch from minutes to eons. Wonder grew, not because the universe became stranger, but because detail made the strangeness specific. By early 1990, the first traveler had done the headline work. Jupiter and Saturn were behind it, the instruments still listening, the cameras nearing retirement. Most missions would have let the cameras rest without ceremony. One more idea asked to be tried, not for science in the strictest sense, but for perspective. Turn around from the far dark and look home. The plan needed care. The cameras were not built to stare near the sun, even from billions of miles away, and no one wanted to burn a sensor at the finish line. But the risk had faded because the camera system was being powered down anyway. Commands were written. On the 14th of February 1990, the spacecraft pivoted and took a mosaic, a family portrait of the sun and the planets as seen from almost 4 billion miles out. 60 images, covering more than 30 degrees of sky, stitched into a lattice of faint lights. In one frame lay a speck crossed by a sunbeam less than a pixel, a mote suspended in a shaft of scattered light. That was Earth. First glance, underwhelming. A point you could lose if you blinked. Second glance, when someone said where to look, everything. Every story, every language, every storm and lullaby, every boundary and healing and argument, sitting on a dust-sized blue. The color comes from the same scattering that paints our sky when you step outside molecules in the air bumping sunlight into blue. Even from the edge, that tint carries oceans, air, a thin envelope that keeps weather and breathing possible. The loneliness of the black around it is honest, not cruel. The emptiness clears a space where meaning can stand. Connection, care, the simple discipline of remembering we share a dot. Others appeared in the portrait: Jupiter, Saturn, Uranus, Neptune, Venus, and the sun itself made a wary cameo. Mercury hid too close to the glare. Mars didn't show well at that angle. The mosaic was as technical as it was tender. Angles calculated, exposures timed, telemetry checked. When it was done, the cameras were powered off for good. The craft would keep listening with other senses. The seeing had said its last word. What followed the image were sentences that many people keep close. Carl Sagan wrote about that pale point as home in full, about how every life and hope and cruelty and kindness and moment we carry lived on that pixel, and about what that should teach us: humility, gentleness, the urgency of protecting the only world that holds us. It wasn't sentiment for its own sake, it was proportion. A photograph became a mirror that fit in a pocket. The lesson folded back through everything the Voyagers had already taught. If a storm the size of a planet can move in graceful eddies, perhaps our tempers can learn a slower turn. If a small moon can hold an ocean in the dark, perhaps possibility lives where we have not yet learned to look. If rings can keep their edges because a few small shepherds nudge particles into place, perhaps large structures thrive on small, consistent kindnesses. If a magnetosphere can wander from its axis and still find a rhythm, perhaps there are more balanced ways to be lopsided than we first assumed. The numbers stayed soft in the mind. Dates of encounters, distances stepped off in hundreds of millions and then in billions of miles, new moons by the dozen, winds at Neptune up to supersonic speed, Uranus tipped by about 98 degrees, magnetic fields tilted and offset, ring systems at all four giants, with their distinct accents: dust at Jupiter, narrow darkness at Uranus, arcs at Neptune, shimmering lace at Saturn. They make a lullaby of facts, steady and true. What matters at bedtime, though, is the tone of it all. The way two small machines showed that quiet work can change the map, that patience can open doors, that attention can make a world out of a blur. They traveled without hurry, sending back a long thread of news. They taught us how much motion hides inside stillness, how much structure hides inside shine, and how many kinds of weather a universe can invent. Somewhere beyond the heliopause, both ships keep going. Their cameras sleep. Their other instruments continue to listen for particles and fields, to feel for the thin breeze between stars. The golden records ride along, each a slow circle of greetings tucked into the dark. Back here, the image of that blue speck returns now and then, like a seashell you take down from a shelf to hear the suggestion of waves. The point is small, the meaning is not. The travelers gave us storms and rings and geysers and tilted dynamos. They also gave us a way to stand very far away, look back, and, in the quiet, remember how to care for a world that looks like a mote in a sunbeam and turns out to be everything. If the solar system were a house, we'd live in the warm room with the big window close to the hearth of the sun, neighbors we know by name drifting past in familiar paths, the asteroid belt like a low stone wall and the gas giants glinting beyond. Houses have edges, though. There's a porch where the light thins, a fence where the yard gives way to field. For Voyager 1, that threshold had a name and a shape you can't see: the heliopause. Crossing it wasn't a snapshot moment with confetti. It was a quiet step that changed what "we've been there" means. To reach it, trade the picture of the sun as only a globe of light for another one, a campfire that throws out not just warmth and brightness, but a steady wind. That wind is made of charged particles and magnetic fields, the solar wind blowing outward in all directions. Over time, it carves a vast bubble in space, a protective envelope called the heliosphere. Inside that bubble, the sun sets the rules. Its magnetic field braids the space between planets. Its particles fill the lanes. Its weather, though invisible to the eye, shapes the routes our machines must take. Every bubble meets a boundary. Far from the sun, the breeze loses nerve, pushing into the sparse material that lives between stars. The interstellar medium, a thin broth of gas, dust, and cosmic rays. The heliopause is the skin of the bubble, the place where the outward push of the solar wind yields to the pressure outside. Names make it sound crisp. Reality is a waver. There is no neon sign, no white picket fence. The frontier shifts with the sun's moods, with the density of the space it meets, with magnetism that bends and flexes across years. For a long time, models drew that border in pencil. Then a small craft arrived to test the pencil line with its own body. In August 2012, NASA said aloud what the numbers had been spelling softly. Voyager 1 had crossed into interstellar space. Not outside the sun's gravity, its pull reaches far past the Kuiper belt toward an imagined shell of icy leftovers called the Oort cloud, but beyond the sun's wind, first of its kind. A human-built object in the space between the stars. How do you know you've stepped off the porch in a night without landmarks? You listen. Inside the heliosphere, solar particles, energetic protons, and electrons are thick on every side. Cosmic rays from beyond are tamped down. As Voyager 1 drifted outward, that ratio swung. Fewer solar particles, more cosmic rays. One needle fell, another rose. The magnetic field measurements added their puzzle. Some had expected its direction to tilt decisively at the border, a clean pivot like a weather vane in a new wind. The field shifted, but not dramatically, and debates rattled the table. Had the crossing happened, or were we still inside a wrinkled edge? The sun itself sent the clarifier. In March 2012, a coronal mass ejection, a great exhale of charged particles, launched into space. More than a year later, that shockwave reached the far traveler. In April 2013, Voyager's instruments felt the surrounding plasma ring like a bell, a vibration that revealed the density of the medium. The value jumped roughly 40 times the density typical inside the heliosphere, announcing a new room, the interstellar medium. Debate softened. The pencil line had become a footstep. Crossing the heliopause is not the same as leaving the solar system, at least in the sober language of gravity. The sun's hold extends unimaginably far, past the Kuiper belt and into that hypothetical Oort cloud that might stretch a good fraction of the way to the nearest star, a cold pantry where long-period comets bide their time. At the Voyager's speeds about 35,000 to 38,000 miles per hour, reaching the inner edge of that cloud will take on the order of centuries, drifting beyond it tens of millennia. But in every sense that touches weather and wind, the crossing was a goodbye. The sun stopped leading and began whispering. Voyager 2 joined the club in November 2018 on a different path and through slightly different conditions. 2 measurements from 2 directions, 2 signatures of the same threshold. In a field where we're often grateful for a single good data point, the twin confirmation felt like kindness. There were no new planets waiting just beyond the line. No curtains of colored gas, no staged surprise. What Voyager found was the quiet richness of the medium itself, colder than our inner lanes, denser than many had guessed, structured by magnetic fields that reach across light years and hum at very low frequencies. The music changed key, but did not stop. The mission changed scale from planetary to galactic and kept the same modest tempo. Interstellar space is not empty. It is sparse and textured, a place where shock waves from distant solar burps arrive thin but real, where rays born in exploding stars wander and tap at instruments patient enough to listen. Distance adds a difficulty that never relaxes. Today, each signal from Voyager 1 takes on the order of a day to make the round-trip light hours stacked into a conversation with long breaths between sentences. Voyager 2 trails by billions of miles on a slightly different bearing, but the choreography is similar. The Deep Space Network giant radio dishes in California, Spain, and Australia spreads its ears around Earth, so the planet's rotation won't turn us away at the wrong moment. What they catch is faint in a way that's hard to feel. By the time a Voyager's whisper arrives, its power has dwindled to something many orders of magnitude weaker than the watch on a wrist. Yet, the pattern resolves. Ones and zeros line up and become measurements on a screen. Particle counts, field directions, the subtle quiver of plasma where the sun's breath meets the galaxies. Aging is the other constant. Each spacecraft left home with 3 radioisotope thermoelectric generators, RTGs, that convert the heat of decaying plutonium-238 into electricity. At launch, the system supplied roughly 470 watts. Decay is steady. The current falls year by year. Less power narrows choices. The team has learned to make trade-offs like someone managing a cabin in winter. This heater stays, that one goes. This instrument sleeps, while that one works. No camera, but keep the magnetometer awake. Save the transmitter until the last light. The cameras went quiet decades ago. What remains are the senses that feel fields and particles and waves in plasma, perfect eyes for a place without scenery. The craft are tough, but not invulnerable. Glitches arrive like odd dreams. In one recent bout, Voyager 1 began returning garbled telemetry from a subsystem, a behavior that smelled like a memory chip gone bad. The engineers, many born years after launch, scanned old documents, thought through architectures drawn in a different era, and crafted a workaround, a software reroute, a gentle nudge sent into the dark. A day for the command to arrive, another day for the echo of success it held. Another time, a long maintenance pause on a southern hemisphere antenna left Voyager 2 unable to hear us for months. When the dish warmed and woke, the craft answered like a distant friend picking up the line on the first ring, patient and ready. The end will not be a sudden cliff. Power will continue to slip, instrument by instrument, until even the transmitter can no longer keep its voice above the noise. Silence will come not as failure, but as completion, a lantern that burned longer than anyone dared to plan. The bodies will keep moving, coasting into the deep, with their golden records bolted to their sides, each a patient letter in a bottle, addressed to anyone and left on the ocean of time. In some far future, Voyager 1 will pass within a few light years of Gliese 445. Voyager 2 will thread a different wilderness and, perhaps, miss every nearby star by comfortable margins. They are not aimed at meetings, they are passing through. Until that quiet settles in, they continue to teach. Direct measurements of the interstellar medium are rare and priceless, and the Voyagers are the only sources we have. The plasma out there is denser than expected. The magnetic field leans in ways that are both consistent and odd. Shock waves from the sun still arrive, altered and slowed, yet crisp enough to make the local medium ring. The data have already reshaped how we imagine the solar system's boundary. Not a line, but a layered region, a sheath where fields twist, densities change, and interactions leave marks that instruments can read. Perspective traveled with the instruments. Stepping into interstellar space does not make our neighborhood smaller. It makes it more itself, a system with a wind, a boundary, and a relationship to the rest of the galaxy. The heliosphere becomes less an absolute shelter and more a weather pattern, one bubble among many carved by other stars, overlapping and pressing on each other like dewdrops on a leaf. Our sun's bubble breathes with its cycle. It shrinks and swells. It pushes and yields. The Voyagers are the hands reaching past the membrane and feeling the temperature on the other side. Numbers hold their own soft poetry. Think of speeds in tens of thousands of miles per hour and still call the journey slow. Think of signal strengths so faint that faint loses meaning. Think of the Oort cloud as a room so large that centuries are the doormat and 30,000 years the hallway. Think of latencies measured in hours and fixes that take days to confirm, patience embedded in every keystroke. Think of cosmic rays, protons, and heavier nuclei, accelerated by distant cataclysms, arriving like rain through a thatch roof, countable at the edge of the sun's reach. These are facts, but also a rhythm. Inhale, exhale, listen. People sustain that rhythm. Controllers turn heaters off like someone dimming the last light on a porch. Navigators watch for the slight drift that would tip a dish out of alignment. Radio operators schedule the deep space network's time with the care you lend to a shared well. Young engineers learn to read documents typed on paper decades ago. Veterans carry knowledge that does not live in diagrams, a feel for how the spacecraft responds when surprised. Each small success feels undeserved and yet earned, a patch that holds, a whisper that returns, a graph that rises where it should. Crossing the heliopause didn't ask for parades. The news ran bright for a while, then folded into the steady hum of other stories. But the threshold endures in its meaning. We have walked past the limit of the sun's wind and into the galaxy's weather. From here, there is no destination. There is only the act of going, of attending, of learning how the room we live in sits inside the larger house. If that sounds austere, it isn't. It is what curiosity looks like when it grows up. Less about flags, more about listening. Less about arrival, more about understanding the path. Some evenings, if you let your breath lengthen, you can almost feel the geometry, the sun's campfire glow, the bubble it breathes, the thin skin of the heliopause, the cooler, denser air of interstellar space beyond. Out there, two small machines with old hearts keep their faces turned toward home when they need to speak, and then turn back outward to feel the wind. Their power dwindles, their purpose does not. They carry data, they carry a pair of golden records with greetings and wails and maps of pulsars. They carry, whether they mean to or not, a promise we made to ourselves, that leaving can be done with care, that the unknown can be entered without noise, that a quiet hello sent into the dark is still a kind of light. Out in the chill beyond the sun's weather, where our star is just another bright pin, and the background hush seems to grow a little louder, two small travelers keep moving. If you could lean close, closer than physics allows, you might hear the faintest metronome inside their bodies, power ticking down, choices narrowing, time doing what time always does. The Voyagers are not failing, they are dimming, like old lanterns nursing the last of their oil and making every minute of glow count. From the beginning they carried warm hearts, radioisotope, thermoelectric generators, metal chimneys that sip heat from the steady decay of plutonium-238 and turn it into electricity. Solar panels would have starved in those far lanes. The RTGs just kept humming, indifferent to night. But even a steady decay is a kind of calendar. At launch, each craft had roughly 470 watts to spend modest, but faithful. Year by year, the output fell, unhurried and relentless. Until now, the budget is less than half the old allowance and shrinking. The spacecraft are not a single switch. They're a village of necessities. Instruments, heaters, transmitters, memory, attitude, control. Everyone needs a little. No one can have everything. So the team has learned a soft art, deciding which room stays lit and which must go dark. Shoot-offs began long ago, not because sensors broke, but because the purse got thin. A magnetometer might stay. A camera, long quiet, gives up its share. A plasma instrument that once tasted the boundary between solar wind and interstellar air finally exhaled and went still. Each deactivation is a small ceremony without speeches. People who have tended a device for decades feel the moment land. Less data flows. The conversation grows slower, quieter, but it continues, and what it says matters. Counts of cosmic rays, the lean of a magnetic field, the soft ring of plasma when a distant solar shock passes by. The quality hasn't soured, only the volume is lowered, like a late-night radio turned down so the house can sleep. Cold is the other constant. Interstellar space is not merely chilly, it is an argument against heat. The RTGs share what warmth they have, and little patch heaters dot the craft, like tiny hearths, kept on or off according to need. Some boxes now run below the temperatures the manuals prefer, tucked in insulation, kept functional by stubborn design and the kindness of margins. Even the transmitter, the throat that still speaks to Earth, must take its turn in the triage of power. The day will come when the last trade can't be made, a final choice between a heater and a voice. Silence won't be a failure then, only a fact reaching its turn. Until that day, ingenuity buys time. Engineers have recovered a handful of watts by rerouting through little-used regulators, by trimming the appetite of electronics that once ran comfortably fat, by finding hidden thrift in a craft built when thrift was already a virtue. Time is the richest commodity left. Every watt reclaimed is another week, another stream of bits, another set of curves on a plot that adds one more brushstroke to the portrait of the space between stars. Missions are often measured in months, sometimes years. These two were penciled in for 5. They have lived nearly 10 times that span because their bones were honest and because their caretakers never learned how to stop caring. At the Jet Propulsion Laboratory, a small team still composes command sequences like quiet music, checks each note twice, and sends it into the dark. A signal needs about 22 hours to reach Voyager 1 now, and as much again to bring the acknowledgement home. Troubleshooting at that tempo is an exercise in patience. Write, wait, listen, adjust, wait, listen. Some of the people typing these messages were not yet born when the craft launched. Others have walked beside the mission for a working lifetime. They pass knowledge like a lit taper from hand to hand, keeping a flame that was struck in another century. Glitches are inevitable at that distance and age. A memory cell wanders. A subsystem starts returning gibberish. The team responds like watchmakers, paging through old diagrams, inferring from behavior, inventing software detours around hardware that can't be touched. A patch goes out. A day later, it arrives. A day after that, the answer comes back. Steady tone, readable telemetry, a problem sidestepped. It's not luck, it's craft, and the grace of a design that forgives human hope. The trajectory extends past any calendar we know how to keep. A few years from now, perhaps, The last instrument will fall silent. Then, on some shift in some control room, the carrier will fade. The spacecraft will not stop. They will continue at more than 35,000 miles per hour, ghost ships of precision and aluminum, each with a golden memory bolted to its side. They will cross the centuries without instructions, without watchers, far beyond the weather of the sun, writing long, unwitnessed arcs through the Milky Way. Those records, two slow circles of gold-plated copper, hold our greetings and our music, our diagrams and our wails. They aren't beacons, they're keepsakes. It's almost irresistible to imagine them found, a quiet workshop under an alien sky, instruments we don't have words for, careful hands teasing open an aluminum cover to reveal engraved instructions, a hydrogen atom drawn as a clock, ratios and pulses. The map of pulsars pointing backward to a moment in space and time where a small world said hello. Perhaps the finders will be amused by our confidence, baffled by the needle, charmed by the idea of encoding images in a groove. Perhaps they will listen. If they do, they'll meet a messy choir, Bach's countersong, bronze bowls of gamelan washing in waves, a Navajo night chant, a Japanese shakuhachi line as spare as winter, a Peruvian wedding song, Louis Armstrong leaning into a phrase, Blind Willie Johnson humming grief and promise without a single word. Chuck Berry will stand there with his guitar and the rough joy of a backbeat. To ears evolved for different seas and winds, all of it might sound like weather. Maybe the laughter will translate better than the melody. Maybe the heartbeat will. They'll hear the earth, too, in the stitched collage of sounds. Surf on rock, wind in trees, thunder rolling, the breath of a rocket, the soft smacking of a kiss, the rattle of a train. A baby announcing its arrival. 55 human tongues will offer greetings, from Akkadian's ancient syllables to the clean line of hello from the children of planet Earth. The pictures will assemble from pulses into scenes that feel as ordinary to us as rain. Hands passing bread, a woman holding a newborn, a page of anatomy and a spiral of DNA. Animals bright-eyed in their own worlds, a supermarket aisle that looks like an art installation in hindsight, a view of our planet hanging in black like a blue punctuation mark. Somewhere among the tracks is an hour of Anne Druyan's brain rhythms, recorded while she reflected on life's history and the first heat of love, an electromagnetic sketch of a private thought offered without apology to whatever minds might learn how to read it. Interpretation is a two-way street. They might shrug and return to bending dark energy into galleries. They might catalog the record beside other curiosities that wash up from younger civilizations. Or they might listen a second time and decide that the jumble is a pattern, repetition and variation, symmetry and syncopation, a language of feeling wrapped in sound. Even if no one ever touches the record, the gesture holds. We made a thing that tried to be generous. We sent it not to conquer, not to warn, but to greet. The largest part of legacy lives here at home. The Voyagers didn't just widen the map, they deepened the appetite. After those flybys, interesting stopped meaning only bright and big. It began to mean active and layered. Moons that remake their faces, oceans under ice, worlds that breathe nitrogen in the dark, rings that organize themselves out of chaos with the help of small shepherds, magnetospheres that refuse to line up neatly and still find a rhythm. Missions followed in the paths they traced. Galileo to read Jupiter more closely, Cassini to court Saturn and walk hand in hand with Titan and Enceladus, New Horizons to whisper secrets from Pluto's heart, Juno to sound the depth of Jupiter's winds. The Voyagers had given permission to ask better questions. They had taught us that surprise is not a failure of prediction. It's the sign that a living system is being seen well. Impact creeps into the calendar in other ways. The Deep Space Network got stronger, not just for them, but for everyone that came next. Navigation grew subtler. Planetary protection grew wiser. Students who pasted Voyager posters on dorm room walls now guide their own craft through other frontiers. Writers and musicians borrowed the image of a pale blue dot to make other points with grace. The word heliopause, once a technical term, slipped into ordinary speech and began to stand in for any edge you cross when you're ready to learn what's on the other side. What endures most gently is the tone. The Voyagers proved that an unflashy mission can become a lantern. They moved at the speed of patience. They listened more than they shouted. They lingered long enough to let the truth of places reveal itself. They showed that care is a technology that you can design for forgiveness, plan for long quiets, and keep your hand steady when the reply takes a day to return. Somewhere beyond the sun's last true breath, the two craft are still balancing their ledgers. A heater off here, a sensor on there. They tip their dishes toward Earth to whisper, then turn away to feel the galaxy's weather on their faces. Their power dwindles, and still they teach. Their instruments age, and still they measure. Their memory carries a small gold promise that we were musical, curious, and prone to sending kindness ahead of us. They go on because that's what momentum does when no one asks it to stop. If one day a quiet shifts across the Deep Space Network and the carriers do not return, nothing important will have disappeared. The paths will still be written into the dark. The data will still be here, numbers that changed how we think about rings and fields and oceans under ice. The records will still spin, unneeded and perfect. And anyone who looks up at the night and feels that old ache of wondering will still have two good reasons to trust it. We built something sturdy and sent it farther than anyone had asked for. We filled it with a hello. In the meantime, the whisper persists. Bits arrive with the calm of falling snow, and people lean forward in rooms lit by monitors to hear them. The house we live in, our heliosphere, breathes in and out. Its skin ripples where it meets the larger weather. Our porch light is faint at that distance. Our address is the pattern of pulsars stitched into a map on a golden lid. And our story, the one told by two small machines with long patience, continues to unfold at the tempo of light. Go gently, hold your course, listen, send back what you learn. Mars once held most of the scientific spotlight, a red stage where our telescopes lingered and our stories took root. Voyager widened the stage. Suddenly, the side characters were leads. Moons turned into worlds with tempers and secrets. Rings became laboratories. Atmospheres revealed chemistry that felt both familiar and strange. Weather wasn't just clouds and wind. It was electricity, threading magnetospheres. It was tides inside ice. It was storms that could hold their shape for generations. The map didn't just grow, it deepened. Exploration followed that deepening like tide into an estuary. Galileo slipped into Jupiter's sway, not just passing, but staying, listening long enough to hear the cadence beneath the thunder. It carried dust detectors and magnetometers, watched lightning flicker inside clouds, and kept looking past the planet toward the worlds that orbited it. Europa, in particular, stepped from rumor into hypothesis. An ocean under ice, warmed by tides, salted by rock, a place where chemistry could hum without sunlight. Galileo did not solve the ocean's story. It made the question honest enough to live with. Saturn's turn came with Cassini, a mission that felt like an answer written in chapters. Where Voyager traced the edges of the rings, Cassini traced their threads, mapping ripples that remember the pull of moons and the whisper of meteoroid strikes. It leaned close to Enceladus and tasted the geysers that Voyager had only hinted at: water, salts, organics, heat breathing through cracks to space. It drifted through Titan's orange air, then handed the moment to Huygens, a little lander that floated down on parachutes through a copper dusk and touched ground beneath a sky the color of tea. Pools and channels cut by methane rain weather, but cold and deliberate. Cassini finished as carefully as it began, slipping between planet and rings in dives that felt like pages turning, then choosing a final arc into Saturn's clouds so it wouldn't risk a future landing on a world that might shelter life. Juno took Jupiter's measure from a new angle, polar and intimate, sounding for deep winds, weighing the fuzziness of its core, tracing auroras where particles sprint along field lines and paint in ultraviolet. The craft's path gravity assists, timed like notes owed something to the Voyager playbook, even as its instruments sang a different song. Other journeys, other echoes. New Horizons flew to Pluto with the single-shot audacity of a postcard mailed to a stranger. Arrive, look keenly, move on. It found plains of nitrogen ice convecting slowly as cooling oatmeal, dark capes, mountains built of water ice as rigid as rock, and an atmosphere that drifts away in a blue haze. People called it Voyager 3 now and then, not to deny its originality, but to admit its lineage: a lean machine, a long cruise, a single chance to make first impressions. Voyager's quiet influence reaches into the cadence of careers, too. A student who saw the first Jupiter pictures arrive could grow into a scientist guiding instruments decades later, or into an engineer who knows how to coax a misbehaving subsystem back to clarity. Missions were funded with longer horizons in mind. Health checks and power budgets began to sound like daily rituals rather than special events. It turned out that if you design for patience, patience will meet you halfway. Beyond labs and clean rooms, the travelers found a second life in imagination. They are not noisy heroes. They did not raise flags or stage landings with dust plumes for the camera. They moved at the speed of thoughtfulness, steady burns, long waits, a willingness to let a picture build line by line. That tempo invited reflection. Films borrowed their silhouettes and asked what it would mean for a machine to come home changed. Documentaries stitched their images into lullabies of data and color. Songs sampled the whale calls and footsteps and greetings from the golden record. In museums and classrooms, that gold disc became both artifact and metaphor, a compact declaration that when we step into the dark, we can carry kindness in our hands. The engineering has aged into legend. Taped commands, analog recorders, memories small enough to fit on a modern thumbnail, yet all of it resilient in a way that still surprises. The high-gain antennas were shaped for a whisper. The thermal blankets were cut and layered like careful quilts. The software was written for clarity, not spectacle. No frills became a compliment. Longevity wasn't an accident. It was a value baked into bolts and code. The science keeps circling to the same truth. Questions worth asking become better when you can listen longer. What shape does a magnetic field take when the planet's core is not a tidy bar magnet? How do rings remember the passage of small moons? What does the sun's wind sound like when it hands the sky to the galaxy's weather? How does the density of plasma change as a solar shockwave arrives tired from the long road? These used to be tidy diagrams and best guesses. Now they are curves on graphs, arguments among friendly rivals, papers with footnotes that brag about the patience of the instruments that made them possible. And still, the missions are tended with a craftsman's affection. Heaters are rationed, voltages are balanced, commands are written softly and sent across a day of silence, then answered another day later. The team is a braid of memory and invention, veterans who remember which connector tends to sulk in the cold, newcomers who read old schematics the way a musician studies a score. When something fails, they write past it. When something wakes, they celebrate without noise. The words we reach for have shifted as the distance grew. Probe, spacecraft, messenger, then, gradually, traveler, then, something not quite a title, a voice. Not the loud kind, the steady kind. The kind that keeps speaking at the pace a human heart can follow. The kind that makes you sit with a notebook and draw a line along a thought you're trying to keep. What it reminded us about ourselves is not a new revelation, only one we forget. We are a species that leans forward. We build to understand, and sometimes we choose to make art where an instrument would have sufficed. We send greetings no one asked for, not to earn applause, but because the sending is part of the meaning. The golden record was not a scientific requirement. It was an act of manners. We included lullabies and blues, greetings in languages no one speaks anymore and languages spoken by billions, the rhythm of a human brain thinking about love and time. We included diagrams rigorous enough to help a stranger find our star. That mixture, precision and tenderness, says more than a manifesto could. Voyager's story has the shape of a bottle tossed from a quiet shore. You don't throw it to guarantee an answer. You throw it to honor the water and to declare that you were here and made something worth sharing. The bottle is still afloat. That matters whether or not it is ever found. Out beyond the last clean lines of the solar system diagrams, the two small ships keep their appointments with distance. No destinations printed on the itinerary, just a long drift through a medium that looks empty until you learn how to listen. Cosmic rays tap the hull and are counted. Plasma waves sing at frequencies too low for ears and are translated into numbers that become music anyway. Magnetic fields lean a few degrees this way and that, and someone at a desk notices. The craft are old now, by any measure we usually apply. They were born in the era of rotary phones and slide rules, when code was typed with more care than anyone applies to a text message. They have flown through radiation belts that would make your skin crawl to imagine, past storms large enough to swallow continents, beyond a wind that once seemed to define the edge of home. What remains is not spectacle, it is fidelity. The signals arrive so faint that faint is hardly the word anymore, but they arrive. They carry no photographs now, only the touch of particles and fields and the low tremor of distant weather. For the people who listen, those bits are treasure. For the rest of us, the fact of their arrival is treasure enough. Listening is a way to practice hope. It implies belief that something real and worth knowing is still out there, that effort spent on quiet truths is not wasted, that attention is a gift you give to the world and to yourself. Some legacies wear capes. This one wears a cardigan. It stands by the window and watches the light change and writes down what it sees. It asks for nothing. It offers a slow education in proportion. The difference between loud and lasting, between new and true. If a child one day asks what it looks like when humanity behaves beautifully, you could point to 2 lines on a star chart and a pair of gold records riding shotgun. Soon, measured in years rather than days, the power will drop below the last careful threshold. Instruments will hush one at a time. The transmitter will grow quiet. There won't be an alarm. The Deep Space Network will listen for a while, then listen less, then fold those hours into memory. The craft will go on, not because anyone told them to, but because nothing told them to stop. If a future being finds one and lifts the cover of the record, they will learn our address written in pulsars and patience. They will hear laughter and wails and steel strings and wind. They will learn that we once made a promise to the dark and kept it. For now, breathing in the hush of your room, you can picture the travelers the size of small cars, their white dishes turned like listening faces, their warm hearts cooling by degrees, their paths widening into the long, slow grace of interstellar night. Think of the questions they leave behind that will be answered by others. Think of the questions they taught us to ask well. Think of the way a pixel on a screen became a moon, the way a crack in ice became an ocean, the way a faint rise in plasma density became a border between home and away. If your eyelids feel heavy, let them. Let the cadence slow the way signals do when distance grows, and let the last bright images drift to the edges of thought. Rings like lace in morning light, a dark blue storm with white clouds stitched around it. A pale dot sitting in a sunbeam, somewhere past the heliopause. Two small voices keep speaking. We listen, we learn, we rest. When breath finds an easy rhythm, hold this small, steady truth. Reaching out matters. Asking matters. A quiet hello sent into the dark is a kind of light. Let it keep you company as the room grows softer and the night leans close. And if sleep comes now, that's all right. The travelers will keep going. The signal will be there when you wake.